Hey everyone, this is Bobby at Copel TV Repair, and today I'm gonna do a really quick, well, as quick as I can, video about how to test power supply board Delta AP-P396AM, which is used in some, I think 80 or 85-inch Sonys. I'm gonna put it in the title of the video and possibly in the subject. When the TV is totally dead, many times this could be because the power board is bad, but it can also be because main board is bad. One very common reason for the latter is, well, there can be different reasons. Power surge that comes through the antenna input or the HDMIs. Sometimes they fail because of natural aging. It can be different reasons. So many times when the TV is totally dead, and even in our own listings, we advertise repair for power supply boards when TV is totally dead, because that's the failure symptom. And then we have other listings for main boards, and again, the symptom is that the TV is totally dead. It's because the brain, it's like the difference between the heart and the brain in a living organism. If either of them is dead, it will still be totally dead. And many times those are confused. And one way to save time and money is to test up front whether the heart is actually working as it's supposed to be. And in case of electronics, this is the power supply board. The best way to test power supply boards is outside of the TV, or rather, they may be still inside the TV, but all the connectors will have to be disconnected, everything that can pull them down. Why is that? Well, because if, suppose the main board is connected here, and two of the many cables that go out and go to the main board, one of them will be for common ground, which will be the same as all the metal connectors that get stuck to the body of the TV. And then the other one will be for the standby power. Now, suppose the main board is shorted for whatever reason, natural failure, power surge, whatever. And let's say the microcontroller on it that is monitoring when are you going to press the power on button or issue a command with the remote is turned on. So suppose that got shorted for whatever reason. And what is happening is there is a short circuit. Imagine literally a wire between the standby voltage and the common ground. Now the power board, if there is a short here, will never be able to provide 3.5 or 5 volts, whatever the standby power might be, because there is a short circuit, because it's not designed to be able to handle the current that, well, it's impossible. If it is a short circuit, it doesn't necessarily have to be short. But anyhow, if there is something that prevents, something like a short circuit, very low resistance, abnormally low resistance, that prevents the standby circuit from raising those 3.5 volts, your TV will be totally dead. If the TV is not totally dead, if it does have an LED on it, the problem may still be in the power supply board, because the power boards go and wake up in different stages. For example, when you have standard power in, only a very small portion, this is a standby circuit here, in this case, is outputting a standby voltage, which is very low voltage, very low current, very low power voltage, and a very small circuit on the main board. And that's an example. It's a different main board for a different TV, but a very small circuit here, very small part of the brain, like when you're asleep, is just watching and monitoring, is there a signal coming from the power or not? And if yes, then it wakes up the power supply board and different circuits on that board, one in different order, and supplies different powers that are needed for different things. Some for the backlights, some for the audio amplifier goes here, and there may be others as well, or more powerful, 5 volts, for whatever is needed. So what you want to check is whether first there is any standby voltage going out of that power supply, and then, if you can, manually test if it wakes up in response. You can emulate the response from a main board telling it to wake up and activate other voltages. Now, the very first thing you want to try is you want to check, make sure that it's not connected to power, live AC, is you want to check the main fuse. and see if the main fuse is good or bad. Way to do that: switch on diode or resistance, test those two shorted together. Most of the units will be just making that bleep when it happens. And what you want to do, again, make sure that this is not connected to a live circuit. You want to test that fuse and see whether the fuse is bleeping. It should be. A fuse is nothing more than a wire. Well, it is a little bit more than that. It is a wire that is specifically designed to melt and blow when the current through it goes over certain things. Do not short circuits. If you find them open, do not replace that blown fuse with a wire. There is a reason that fuse was blown. There is something else that would have been blown here. I have a separate video that goes into details and explains why it's a bad idea to replace fuses with wires. Now, in case of that board, when you see that is fine, the next thing that you want to do is you want to power on the board, and you're going to be looking for standby voltage. Before I do that, again, make sure that everything else is disconnected from that board. And now, there are several different ways and places to look for standby voltage. The classic and most simple and most natural way to go, unless you're experienced, is to look at the connector that goes to the main board. And in case of this power supply board, there's only one, that is the connector. And usually, especially the good manufacturers, have somewhere around it a diagram that or detailed table that shows where on this connector you have what signals. And this is called connector 6401. It should be printed, yeah, here, 6401. And it's labeled. It's 2 rows of connectors, as you can see, top and bottom. And they're labeled 1 and 2. So the one on the right side are the odd ones. The one on the left side are even. So it is 1, 2, and then to the left 3 and 4, 5 and 6, and so on and so forth. So on the bottom here, starting from the right going towards the left, we have 1, 3, 5, 7, etc. And on the top we have 2, 4, 6, etc., etc. And if we look at that table, we find that standby, you're looking for something that will be saying STBY or just SB underscore, or sometimes something that will be showing standby. Most of the times it will be labeled that way, not necessarily always. It's not a law, it's not a requirement that they have to do, but it's a pretty common practice, and most, especially if the good manufacturers, have it that way. So this one says that on pin number 5, we should have standby 3.3 volts, and that means this is here, not the first, not the second, 1, 3, 5. The third pin on the bottom, right to left, will be 3.3 volts, and this is standby voltage. Now, most the ground, you can see where the ground is, but really probably the best way to go about it is to look for some of those corner screw places, screw holders, or something like this, and that is a very reliable ground. Do not assume and do not often take heat sinks for ground for a number of reasons. Many times they are, but there are times when there aren't. So in this case, I'm going to be plugging in power, and you can do that again while the board is inside the TV. You can do it while it's on a bench like this. What I'm going to do is I'm going to stick that here so that I have the ground, hopefully somewhat reliable. Oops, not so reliable, sorry. Okay. And I can go about going the 5th pin here, but many manufacturers, and in case of these boards, many of them will have the necessary voltages somewhere around those wires that are around the connector. And in this case, it's actually on this, oops, switch to voltmeter. And when I'm measuring, it is here. Is it the top one or the bottom one? No, it's the top one, but my ground is not stable, so let me fix that. Make it a little nicer. And okay, a few more. Nope. That should be good. Oh, come on. Okay, let's take the up one. Sometimes, not all of those have to be grounded. I just assume there will be a ground here, and it might or might not be. One way to check, of course, is with a meter. Another thing that I may have done is when I tested it with the ohm meter, I may have cut it off. So what I'm going to do is I'm going to disconnect it and then power it on back again. Usually you wait 30 seconds or so before you do that again, because when I tested it with the ohm meter and you heard it beeping, it may have blocked the circuit so that it doesn't produce the output voltage anymore. Now this board was repaired and I know it is working. I'm probably just taking it off the wrong place, so I moved the connector to a different place. Alright, let me see this one. Yeah, okay. It is this one of the 3 ferrites that are here, or ferrets. I don't really know how to pronounce that. I do apologize. But this one, the bottom one, is where you can test the 3.4 volts. I'm not holding it very steady. That's why it's jumping. And I got the ground up here. I'm pretty sure you can get it down there as well. Okay, well, sure, but it's not. Oh yeah, it is. Alright, so the next thing that you want to do, this have 3.3. The next thing you want to do is you want to look for a pin that activates the power supply board, and a number of things happen when you need that. This is again some very small circuit, and what you're looking for in the table is a pin that says PS on or power on. In this case, you can see that is pin number 9. Normally, in standby mode, there will be nothing else. Now, there are exceptions to that for many boards. But for this one, what you're looking for is the standby, and it's not abnormal if you don't find anything else. Other things will only appear when the board is told to wake up, when the TV is told to start working, by the little voltage that's supplied from the standby power. And what you want to do, without using other boards, you will need something like a jumper. You can manually do this with a tweezer, but it's kind of more difficult. Those you can find for like 50 cents or 30 cents or 10 cents or a buck, bag of 20 for something. They have the small holes here that are actually used for other purposes. And there are some people say that you got to do that through a resistor and so on and so forth. And there's some good reasons for that, but literally 100% of the time it would work without it. What you want to do is you want to send back 3.3 volts or standby, or in other boards it will be 5 volts. You want to send those back to the pin that is called power on or standby. In this case, we take out of pin number 5, 1, 3, 5, so the third one, 1, 3, 5, and we put it to number 9. So we skip one, and the one afterwards will be if it is quiet enough and if you're used to it, you will see slightly different buzzing coming out of the board. And in this case, I'm going to put the ground here again, just lean it up. In this case, you will also get 12 volts right here. And that's one of the outputs out of this connector. Again, you can get it on the pins here. You can see that pins number 13, 14, 15, 16, 17, 18 all produce 12 volts. And this is the 12 volts. And I'm not touching the pins here so that I don't do a short, as I told you, many of those. And then you find which ones. Some of the manufacturers label them, and you can know that you can measure it here. Some of them do not, but there are usually a lot of jumpers around the connector that are good for testing. In this case, this is one of them. if the board is waking up fine, you will find one of the other voltages and hopefully all of the others. Now, it's not all of the others. Why? Because there's another pin that needs to be activated. That's pin number 26, as you can see. It's called T-con on. So we need to send 3.3 volts there as well. And then on pins number 25, 27, and 28, we should see VCC 12 volts. I'm not going to do this now. It just requires another jumper. And you can get 3.3 out of anywhere. Don't get 12 to send them somewhere. You may need to split here. You may need to solder them poorly another way. You can make a connector like we do and show on many other videos that is useful for testing. One thing that I'm missing here is that when the board is awakened, when it's told to wake up, those are main filter capacitors. You cannot confuse them with anything else. They're the biggest capacitors on the board. If you look at them, you will see that they have voltage rating of above 400 volts. Those are 570 volts. And when the board is awakened, this is pretty major and a common source of failure, you should be able to measure on those around 400 volts. That tells you that a very major circuit, it's called the power factor correction circuit, is working. It's not going to be measuring this voltage when I just disconnected it, when the board is not connected. If I go there, I will see that voltage dropping down, discharging, because that circuit is not active anymore. It's discharging slowly, but it is discharging. Over time, if the TV was active and if it was actually consuming power, it would have been discharging faster. Currently, it only again uses very, very small portion of that. Well, that is not all. Again, a proper test would have tested the 12 volts for the T-con when this is activated, and many power boards like this one also has an output for the LEDs, which is on a separate connector, and which is oftentimes and always actually driven differently. Like there is a backlight on here pin that needs to be activated, but in case of LEDs, that oftentimes comes with additional complication because it requires signals for regulating the brightness or receiving and keeping up an error code, which are not that difficult, but it's a little bit beyond what I'm trying to show. The reason I don't want to get into it in details is because the truth is backlights and backlight drivers go bad extremely rarely. 99% of the